Assalamualaikum warahmatollahi wabarakatuh. My name is Aimi Najla Binti Ahmad Tazli. I will present for the introduction of this project. So for content and topic outline, firstly is to apply the knowledge on structural mechanics and solve practical problem by constructing a scaled-down model of a bridge. Secondly, determine mechanical properties of chosen design such as internal forces and deflection. Third is modeling and simulation of the bridge performance. And lastly is to decide a material used for the bridge. So there are several types of bridge truss that had been invented. For this project, we chose Pratt Bridge Truss for our bridge design. And we decided to use steel as the material for our bridge design because steel has high compressive strength and tensile strengths. Then we proceed the bridge design with the basic dimensions, which is the length of the bridge is 40 meter, the width of the roadway is 7 meter, distance between the truss member is 5 meter, and the height of the bridge is 5 meter.
So thank you, Aimi Najla. So before I continue our group presentation, my name is Shahmi and Hashim and my matrix number is TF200169. So I would like to present about design and layout. As we know, we choose our design for this project is Pratt Bridge. So our design have a length of bridge about 40 meters and height 5 meters, and we have about 39 member and reaction 3 that consists pin support at A node and also roller support at I node. This bridge have 16 joints. And this design result get statically determined. So we have put forces at C node at 117.72 kilonewton, and also at the middle of our bridge about 460 kilonewton. Next, this is our cut section design that show our reactions at support A. Have 318.29, and also this is for the calculation internal forces, and this is our result for internal forces bridge. So I will pass to Aina Aidid.
Assalamualaikum warahmatullahi wabarakatuh. My name is Irdina, so I'm going to explain about the manual calculation for the Pratt truss bridge. So these are the information given in the journal that we use. So for the degree determinacy, we get 32 equal to 32, which is statically determinate. And then for the self-weight of a truss, we use a Fuller formula, which provide the span of 30 to 90 mm, 90 meter. Then for our bridge, we are using 40 meter. Then we get 460 kilonewton for point load. And then for the live load, we change the kilogram into kilonewton. Then we get 117.72 kilonewton. Then for the cross-sectional area of member, we are using 2000 times 1000 millimeter that been given in the journal. And then for the modulus of elasticity, based on the information given in the stat pro, we change the key per inch square into GPA. Then we get 199.948 GPA. So for the reaction calculation, first we start with the reaction at support. We are using 3 equilibrium equation, which is moment, Fy and also Fx. And then for the reaction Fiy, we get 259.43 kilonewton. And then Fay, we get 318.29 kilonewton. And then Fax, we get 0. And then for the internal reaction of the member, we are using 2 methods, which is first cut section method, that we get FEF, FML, and also FELY. Then we after that, after we use the cut section member, we are using the alternative method. Then we get all the information that we need. Then move on into the reaction at support after replacing 1 kilonewton reaction at E. As usual, we are using 3 common equilibrium equation, which is moment, Fy, and also Fx. And then after that, we replace 1 kilonewton. After we replace 1 kilonewton, we also need to find the internal reaction of the member. And then there's in the table show in the slide are the result that we get from using the inspection method. Okay, so this is the bridge that we've been used, and all the information that we get from the calculation that we are already provided in the bridge. So for the displacement, 73017.43 times 10 to the power of 6 divide by 119.948 times 10 to the power of 2 times 20000. Then we get 30.437 millimeter.
So thank you, Aina Irdina. So I would like to continue our group presentation. So this I will presenting about our Step Pro calculation. So by using this Step Pro application, we will get the result of pin maximal axial force at each node in our bridge design. And also by using this application, we will get our deflection calculation. So based on node 7, where there is 1 kN vertical reaction be placed, so it will get negative 0.752 in for live load, and also negative 0.219 in for dead load. The value is negative because the displacement is acting downward. The displacement from Step Pro is 24.663 millimeter, while for manual calculation is 30.437 millimeter, which are slightly different. Thank you.
Discussion and summary. Pratt Bridge Design, where the bridge is designed with a single tension diagonal in each panel and compression vertical with parallel chords and an inclined end post. The bridge will fail and break if its internal force, which indicated by external force, become larger than its strength. When load is applied to the bridge, internal forces such as tension and compression between the members. Thus, the bridge strength is important to make sure the bridge is safe enough to be used and prevent from incident happen. From the calculation, we managed to make a comparison between manual calculation and Step Pro calculation, which have some difference. Where the manual calculation value for joint E is 30.497 mm, while Step Pro calculation value at joint 7 is 21.664 mm. As a result, partial safety factor can be lowered while structural reliability is maintained. More research can be improved our understanding of strength and loading, allowing us to change partial safety factor.
Hi, I will present the conclusion of our project. What we can conclude of our project, we learn and comprehend how to determine and analyze reaction and internal forces. We can also compute the force acting on each member of a bridge that we choose and determine the type of force acting on each part. Next, we study how we calculate the forces and how we use the software to determine the forces using Step Pro. From there, we experienced that the software showed the accurate result of measurement of shear forces and bending moment. Last but not least, there are three main types of forces, that loads, reaction, and internal member forces that are very important in ensuring the bridge structure. That's all from us. Thank you.